Alright, two more sections for Chapter 4 and for the semester. So we're about to talk about the whole reason that this idea of logarithms was invented, and that was for us to be able to solve for an exponent. And so what I've got here is a sheet that has got all the steps, everything necessary for all the different kinds. Now I've got type numbers that really are not that crucial that you say a type number, but what you do need to remember is that we're solving for an exponent. So we have a number raised to an exponent power, and an exponent is a variable. And I need to show you what is it that we do in those situations. Okay, so I want to backtrack here to show you a couple examples. So example 1 is if you have 7 times 6 raised to the x plus 2 power is equal to 28. I need my calculator handy eventually. Okay, we have to isolate the number that's raised to the exponential power. So we have to do step 1 first. So step 1 is necessary. It wasn't necessary in this example, but it is necessary in the example I'm about to do. So what I have to do is to get rid of this 7 times, so I have to get rid of multiplication by doing division. So I have 6 to the x plus 2 is equal to a 4. Next step is the thing I could do to any equation as long as I do it to both sides, and that is I want to take the log of both sides. So this is step 2. And it doesn't matter which base we use as long as we use the same base. Okay, now the third step is to use the third property of logarithms, so that means it's x plus 2 parentheses. Even though there's none written, it's understood to have a parentheses here by order of operations. So you'd have the log, or x plus 2 parentheses times the log of 6 is equal to the log of 4. And now we just have to solve this for x. So there's a couple different ways to do it. I could distribute the log of 6, but honestly I think the easiest way to do it, if I don't erase everything accidentally, is to divide both sides by the log of 6. So when I do that, I'll be left with x plus 2 is equal to, because these things divided out, whatever the calculator gives me when I divide these two things. So I have one more thing to do, and since I'm running out of room, I'm going to show it this way, where I'm adding a negative 2 to both sides. So my answer is going to be whatever the calculator gives me when I do the log of 2 divided by the log of 6 minus a 2. Let me do that on my calculator. I think I'm going to pause it while I do that. So when I do this on my calculator, the number that I end up with is this one right here, this negative 1.613147193. That's a 7 right there. So if I round to the nearest hundredth, the answer that would be acceptable is that x is equal to this negative 1.61 that you end up with right here. Alright, so I'm going to count for a couple seconds here and see if you have any need to copy anything down. If you do, you better pause. And then I think I'm just going to erase this particular page and do another example. Alright, so it's going to go completely away here. So example 2. This time it's 5 times e to the 2x is minus 3 is equal to a 32. And I'm trying to be nice to us here so we don't have to worry about fractions, but at some point I'm going to have to stop being nice. But here's what we need to do. We need to solve for x, so I have to isolate the e to the 2x first. So I need to add 3 first. And I have 5e to the 2x is equal to 35. And I need to divide by 5. That's what I was talking about. I get e to the 2x is equal to a 7. Sometime it's going to be a fraction in oh well. And now this time I want to do the natural log of both sides. If you came to Wednesday's session, we kind of already started talking about this stuff. I can take the log of any base that I want, or with any base that I want. Now the reason I do this, when I do step 3 and I rewrite this as the exponent becomes the coefficient using the third property of logarithms, we should know and remember what the natural log of e is equal to. Let's try that again. This is e to what power gives me an e, and the answer would be 1. This thing is a 1 right here. So that makes this whole calculation a lot more easy. I would just divide both sides by 2, and I'm ready to get my calculator out and figure out what this is. I think I can do this fast enough. I don't need to pause this. And the answer I get is 0.972955075, which is going to be 0.97 if we round to the nearest hundredth. So that's the kind of thing when you're solving for an exponent. Now there's 2 applications that we could talk about here. I don't think I want to do both of them right now because we'll probably do them later when we do some things in section 4.5, but we discussed one of them the other day. So we're going to do this one this time. So I'm going to erase this page again so I can do another example. Hopefully you pause me because it's going away. So example 3. Alright, I want to know how long will it take an investment to triple. Well, I think I did triple in class in the Zoom session. Let's do double. If it earns 3% compounded quarterly. Now, when I did the example in the Zoom session, I gave you an amount of money, but I really honestly don't need the amount of money. The principal is whatever it is, and so if I want to know how long it takes to double it, it's just going to be, the new amount is going to be twice whatever the principal is. You could put $1 there, you could put P there, you could put $1,000 there, it doesn't matter. To double it, it's just going to be 2 times whatever the initial amount is. So again, I'm using this formula, which you do not have to have memorized, but you do have to know what quarterly means. Quarterly is referring to n equals 4. You can't see that in this version. So that you need to know. I'm not giving you that. So if you plug all these things in, you would have 2p is equal to p times 1 plus, and then 3% is 0.03 divided by 4 raised to the 4t power. Because we're trying to find t. How long is t? Now, I could get a calculator out and do some of these calculations, and I will in just a second, but honestly, I'd like to get rid of the p. So I'm going to divide both sides by p, and I end up with 2 is equal to 1 plus 0.03 divided by 4 to the 4t power. Now, I believe I know what 0.03 divided by 4 is, but I'm going to go ahead and make sure with my calculator. And I might have not had the right decimal, but this is going to be 2 is equal to 1.0075 to the 4t power. So the question is, have we got it isolated? And the answer is yes, we do. And so now I have to use the third property. Well, I can't do the third property. I've got to do the log of both sides first. So I would have the log of 2 is equal to the log of 1.0075 raised to the 4t power. Now I can use the third property of logarithms, and that coefficient or exponent becomes a coefficient. So I have 4t times the log of 1.0075. So to get the t by itself, don't you dare subtract. You've got to divide by whatever this number is. And honestly, I'm going to let the calculator do all the work. Because this divides out, and this divides out, and so I'm left with a t on the right side. And now I just need to do that calculator work. I think I'm going to pause myself so I can do it. Alright, so let's resume recording here. I'm going to go ahead and on my calculator take the log of 2, divide it by 4, and then divide that answer by the log of 1.0075. And I end up with this long decimal number, which I'm going to round to 19.26 years. Alright, so I will do one more example here real fast with compounding continuously, but then we need to move on to the other types. So pause me, I'm about to erase all this. Example 4. So how long will it take an investment to, we'll go back to triple just to be different, if it earns, and let's get ridiculous, 13% compounded continuously. So this time, because it's compounded continuously, we have to use our PERT formula. And again, the A is going to be, since it's 3 times we're worried about, the A is going to be 3 times whatever the principal is. And then the rate of interest is 13%. So I think I can just plug it into the formula. 3P is equal to P times E to the 0.13 times T power. So again, divide by P. I get 3 is equal to E to the 0.13 T power. So I have isolated the number being raised to a power. And this time I definitely want to do the natural log of both sides. So this is just the natural log of 3, and this by the third property of logarithms is 0.13t, the natural log of e, but we know that's a 1. So all I really have to do is divide both sides by 0.13. And so our answer, once I don't drop the calculator, 3 natural log divided by 0.13. And I messed that up, so let's do it again. And the answer I get is 7.6923076692, or better known as 7.69 years. So that's what you do with the E involved, is you definitely want to do a natural log so you can save yourself the hassle of worrying about trying to divide by the natural log or the log of base 10 with a number like E, the log of E with a base 10. Alright, so that's the first type. The second type is here. Ooh, that didn't come out as good as I'd hoped. Not very good at all. Well, the good news is this worksheet or this set of notes is on Canvas. So you can print this out and get a better job than this. My other option is to see if I've got it handy and I can take another picture real fast. So I think I'll take another picture. Okay, that picture is a little bit better, darker, but it's still better. This is a second type, but I don't really want you to know it by the number. It's solving a single log equal to a single log with the same base. So I've got an example here that you kind of do it all, and I'm going to talk you through these examples in just a second, but if you have 2 logs equal to a single log with the same base, you got to use your properties of logarithms so that you get a single log equal to a single log. Once you have that, then you can do your logic step, that's squiggly line time with a word processor. And then you end up with your equation and you solve the equation. And even though I did it right and I know those are correct answers algebraically, I still have to check my answers. This is imperative. And you'll see in just a second why, because sometimes you try to, when you plug that number in, take the log of a negative number, and that is not allowed. So here are the steps. It's a handout that's on Canvas. Study it, do cards on it, whatever. You need to be prepared for that. And so I'm going to get my examples out, and we're going to do one that's different than this one. Okay, so I'm going to backtrack to this page, and I'm going to do a different example of that. So this example, let's go to a different color. This is of a single log equal to a single log. Let's do a very easy example. If I have 3x minus 1 with a base of 10, and that's equal to a log of, a 7 with a base of 10, then I don't need to do the first step. I could just do my logic step of setting these things equal. And then I can just solve this using techniques that we already know. And I get an answer of basically 8/3, or Juliana's not going to like it, 2 2/3. And so what you want to think about here, yes, I did no mistakes, I made no mistakes, but I still have to check it. And what I'm checking it for is to make sure that the 3x minus 1, when I plug this x back in there, is not going to be less than or equal to 0. So if I have 3 times 8/3 minus a 1, this is going to be 8 minus 1, and I get a 7. And since that 7 is good, it's a positive number, it's not less than this, then I know that this is going to be a case that it's an okay solution. It's one that I would count. So there's a quick example. I don't think I'll be that nice to you. I think I'm going to see if you know some of the stuff we did on the first test when we had to do the quadratic formula. So I'm going to count to 3, and then I'm going to erase this and do another example. So if you didn't pause me, it's too late. So here's my another example, example 2. If I have the log of x plus 2 with a base of 7 plus the log of x minus 5 with a base of 7, and that's equal to the log of 8 with a base of 7. And we're supposed to solve this. Well, if we're going to solve this, we've got to rewrite it so we have a single base, single log equal to a single log. So when you have addition, that's the same thing as multiplying the two numbers by your first property of logarithms. You need your properties of logarithms. And then it's squiggly line time. I'm going to even give you a color. It's orange squiggly line time. And I can then set these things equal to each other because the bases are the same. If the bases aren't the same, then we'd have to do something more, and we can talk about that in a pre-calc class. So how do you solve that? Well, you better remember the zero product rule, which means you have to multiply all this out. So you have x squared minus 3x minus 10 equals 8. And people don't know what to do here, but if you remember your first test, which you darn well better, especially if some of you are going to take a final this time, and that is x squared minus 3x minus 18 is equal to 0. So what factors of negative 18 add up to a negative 3? And the answer is going to be a 6 and a negative 3 as the answers. Okay, I already did the zero product rule in my head. Now I'm sure I made no mistakes. Too bad. I have to still check it. So when I check this, then, what I'm going to have to do is plug it in, and I don't need to plug it in to the whole darn thing. I just need to go back to the beginning, and I'm focusing in on those things. So if I have 6 plus 2, is that greater than 0? Yes. If I have 6 minus 5, is that greater than 0? Yes. So 6 is a perfectly good answer. But if I do negative 3 plus 2, is that greater than 0? No. So I have to toss this. Not because negative 3 is bad there. It's because when I put it back in, I still got a number that was negative or 0. So you have to check it, and I can promise you there'll be a problem sometime where they're both negative or they're both positive, and one will work and the other one won't, and you need to check it. Alright, so I'm going to move on here. There's the third type. So count to 3. And I have another picture for this one. This one's a better picture, so I don't have to redo it. This is when you have a single log equal to a number. If you don't have a single log, you got to rewrite it using your properties of logarithms like we just showed you. And then the next step, step 2, is rewrite using the definition of logarithms. I told you need your properties, you need your definition, you can't live without it. So 2 to the third power is equal to this expression, and I promise it's going to be factorable, like you see this one. And then again, you got to check your answers. One of them will work, one of them won't, because when you plug it back in, if you take the log of a negative number, that's bad. And so here's the check over here, and I'll let you look at that yourself. Again, there is a handout, and if you don't study that for your test, that's bad, 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 because I guarantee you're going to have one of each type here on your test. Guaranteed. So if you don't study it, that's a mistake. Alright, so let me do an example that's different than that one. Specifically, I think I want to do this one. I want to do it in black. Alright, if we had something very basic, let's not do natural log, let's just do log, and I have x minus 7 is equal to a 2. And the question is, how do you solve this? Well, you have to understand that the base is understood to be a 10. So when you rewrite this by definition, you're going to have 10 to the second power. The base to the exponent is equal to x minus 7. So you square that, because you have to follow order of operations, and you add a 7 to both sides, and you end up with 107 is equal to x. And even though I'm sure I did it right, I have to check it. So 107 minus 7, is that greater than 0? And the answer is yes. So I'm good. Okay, I know that this is done properly and it does check out. So 107 is my answer. Count to 3, and I'm going to show you one more example. Okay. Example 2, and I'm sure we'll be doing a lot of these when we do our video session on Monday, but it is the log of x minus 3 with a base of 2 plus the log of x minus 1 with a base of 2, and that's equal to a 3. So this one is not a single log equal to a number, it's two logs. To turn it into a single log, you have to do your first property of logarithms that says if they're added two logarithms, that's like multiplying two numbers with the same base. So I multiply the x minus 3 and the x minus 1. Now, I can go to the second step by definition. This is what a lot of people forget. It's 2 to the third power is equal to this, x minus 3 and x minus 1. A lot of people write that as that it's equal to a 3, and that is not the case. You have to rewrite it by the definition of logarithms. So you have 8 is equal to, and I'm going to go ahead and multiply it because I know I have to. So I have 8 is equal to x squared minus 4x plus 3. So I need to subtract 8 from both sides. And I get 0 is equal to x squared minus 4x minus 5. And I need to factor that. And again, I promise you in a stack of algebra books they'll be factorable. I'm not going to do that to you. And so I get two answers. Again, I don't make my decision based upon what kind of numbers I see here. I have to plug them back in to see what happens. So if I put that 5 into this, 5 minus 3, is that greater than 0? Yes. And I plug it into this, and is 5 minus 1 greater than 0? And yes. So this answer is fine. When I plug that negative 1 in there, negative 1 minus 3, is that greater than 0? And the answer is no, so I toss that out. Okay, now again, in an ideal world, if maybe that was a positive 1, I still would toss it out because a positive 1 minus 3 would not be greater than 0. So you got to check your answers. I'm going to know whether you check your answers. That's why I love giving ones like these examples where you have to use your properties and get 2 possible answers and one of them doesn't work. I want to see that you check your answers. So the key step is one time you do it by definition. Another time you just do a logic step because they're the same base. And then the other one is you've got to do rewriting, you've got to take the log of both sides and then you rewrite this using the third property of logarithms, and this is where you're going to the third property to get this part of the expression. Actually, this part of the expression. Alright, so there are your 3 types. You better study all 3, and I'm sure when we get to time in the class, we're going to be doing more examples.